of f is a subset of AB. Right? Remember that the support of a function is the set of points on which the function can be non-zero. So, yeah. He says, well, this is a vector space, and as a subspace, it's a subspace of the Lebesgue integral functions. It's a norm space, assuming that you're identifying functions which are equal almost everywhere. So it's not really a norm space, but it's almost a norm space for the reasons we discussed before. And the norm is defined by what? What do you think the norm will be here? In this context? Yeah, the definite, right, exactly, this guy. But as usual, absolute value f, right? And that is section 2.9. Now section 2.10 is something we've all been waiting for. All right, so section 2.10 is about, Lebesgue versus Riemann. And so like the introductory theorem is a Riemann integrable function is Lebesgue integrable, and the integrals are equal. So we'll go through that next time. I don't want to do that today. And then he proves also that basically he looks at the proof of f. I think there's a proof of that the Lebesgue integral gives you a continuous area function in some sense, I think, and also that the area function is an antiderivative of the integrand. That's his theorem 2.10.3. And then he's got the change of variables theorem is in there. So he's got basically a proof of the FTC, fundamental theorem of calculus, as it goes through here. And then section 11 is on Lebesgue measure in R, and that's where we'll have a definition of measurable set and all that. Past that, I think he talks about integral of the complex valued Lebesgue integrable functions. That is a very silly section. I'm not sure I'm even going to cover it because it's like we're talking about complex valued functions of a real variable. So the integral is still over the real variable. It's basically just doing like a pair of these integrals or something. It's not. I mean, we'll look at it, but it's yeah. So the independent variables are, and it's not really. I mean, is it complex? Well, I mean, yeah, but I don't know. And anyway, so that's where we're going, and hopefully next time I'm really hoping. I really want to say what I want to say about this chapter this week. Like we're done with this part of the course this week. If I unless something bad happens, but that's my intention, is to say what I have to say about this material this week and then go on. Because I could drag it on, but I think I'm eager to get to the Hilbert space chapter, and so like after this week, I think we're done with this. And work some homework problem. I guess I was supposed to tell you guys which ones to work. Because I haven't done that, but I may yet do that. Don't wait for me to do that. Just start working them. And if I make a list, if I announce a list, then you will tell me, Dr. Cook, I did such and so forth. Could you add it to the list? And I'll be like, sure.